If you place a charge on point O, this is the point O, in the case above, why is the net electric force on the charge O 0, but the electric potential not 0? Let's understand two things here. Net electric force is the acceleration that this charge would experience. So which way would it flow is the question. So easiest way to think of this electric potential is, or the force is, thinking of this as a contour plot like this here. So we got this positive Q here and positive Q here. So positive Q, positive Q. So this is the landscape that it makes. And the question are two. One question is, what is the net electric force? That is, if you place a ball here, which way would it flow is the question. Now, it is hard to believe, but in theory, if you put it right on top of this hill here, it would not flow because it doesn't know which way to go. Because it could either flow to the left, flow to the right, but if you're truly in the center, it is balanced. That's why it is 0, the net force. Now, what about the electric potential? Electric potential is about how much you have to climb to reach there. See, you got to climb quite a bit to go up there. So that's why electric potential is not 0. It's something positive there. So electric potential is, if you're coming from far away, from a distance, how much would you have to climb up to reach there? See, as long as you got to climb up or climb down, then it's not 0. If you can just go straight line without going up or down, then it is 0. So the case is easier to understand when you deal with this one positive and one negative. So I will make the other guy negative here. So this is what we have here. To make it more dramatic, I will bring them closer together. Okay? Okay, now, if I place a ball here, wouldn't it flow? Yes, it would. It would just roll down, right? So that's why the net force is one direction. So here, in this case, even more confusing, why is the electric potential 0? Because you could go in a straight line without going up or down to reach this point here. So to reach this point, you can just go on a straight line without climbing up or down. So whenever they are talking about electric potential, think of going up or down. But the net force is not 0 because it's going to flow. So here's the interesting observation the student asks. So here, everything you said is true. Doesn't it mean that this net force is 0? If the net force is 0, then the potential is also 0? No, because net force is a vector. So vector could be 0 when there are a lot of forces acting on it. For example, here. Let me make them apart here. So at the center here, the vector is 0 because it doesn't know which way to flow. So it's kind of ironic, right? So you can say if you have two friends pulling one each arm, you're about to be torn apart. But you got to say you're stable in the middle. You don't feel pushed one way or the other because you're pushed from both directions here. So that's why net force is 0. But doesn't mean that the height is 0. To get there is the height. So electric potential is a scalar, and the net force is a vector. So that's why you can have this ironical result.